Hello, this is Rafin. I'll be taking your energy conversion lab. I'm one of the instructors here. So, in today's class, since it is the first class, I'm gonna actually talk about this platform since these courses will be entirely on online platform. So this is called Canvas for FIU. So in here, you will see everything about this course, the syllabus, modules, announcements, discussion, assignment, quizzes, grades, everything. If you have a Zoom session, then I will be posting the Zoom link over here so that you can actually, we can have a live session. So on top of that, uh, if you need anything, like for instance, we have discussions here. If you have any questions, you can actually um, text me, email me, or um, we can have a live session if you want. So if we look at the home page, so on this home page, you will see my description, my email address, some key bullet points, and especially the another important thing, which is technical support. If you have any problem, so FIU Canvas help team will guide you, will help you. Now let's go to the syllabus. So this is the syllabus section. So this is course description and purpose. I would like you to actually read all of them. The objective of this course, why we need this course, what are the objectives, so what are you going to learn from this course, because this is a lab. So uh, it is actually directly linked with a course which is called Power System 1. So the course is designed such a way, I mean this lab and that course is designed such a way that one of the lectures that will be given for Power System 1 will be directly linked with this one. So no matter what you learn over there, you will see it, like you will see the practical use of it, like practical application of them. So, and then we have topic covered. What are the topics that we are going to cover? Like say, for example, we'll talk about magnetic circuits and transformers. Then we'll talk about rotating electric machines. We'll also talk about renewable energy technology. So, relation of this course to program outcome. So, since you're all gonna like have a graduate degree, so this course is directly linked with that, um, like that program, which is electrical and electronic engineering. So the relation between this course and the actual program outcome, it has to link. So a student who will actually will be done with this course. After this course, he will be able to design and conduct experiments as well as to analyze and interpret data. So I'd like you to actually read all of them. So I have put general rules and evaluation method. So I have mentioned here that there is a lab calendar. So if you go to module 1 and see lab calendar, so you will see the course outline. So let's go to module, and so this is module 1, which is introduction to energy conversion. You will see materials here, and I haven't actually put all of them. I will be, when you actually see this video, this is a pre-recorded version. So when it's gonna be published, you will see other materials here as well. So let's look into this one, which is lab calendar. So there are 5 modules in this course. One is the first one is Introduction to Energy Conversion. Let's open it here so that you can actually see it properly. So this is Introduction to Energy Conversion, which is module 1. Under this module, there will be 2 classes, 2 lectures in 2 weeks. So in week 1, which is lecture 1 as well, will be on review of basic electricity. So I actually, although it's not, we're not gonna do any experiments here, but I have actually named it experiment 00A. Why 00? As I told you that I'm not gonna actually experiment anything here. You will not see any experiments. This is a review class. Then on second week, we'll be covering fundamentals of magnetic circuit. It is basically in this section or in that lecture, you'll see uh, some physics like related topics, magnetic circuit, which is a physics related topic, and electrical engineering, of course. So we'll talk about magnetic circuit because in energy conversion, especially electrical energy conversion, electricity and magnetism are the most crucial aspects. So with those knowledge, we'll be able to actually convert energy from one form to another. So we'll actually review this and also we'll learn something new on lecture 2. Then after lecture 2, we could have actually started with experiment 1 from day 1, but I have chosen not to do that because we need to review some basic stuff, and also you need to learn the, what is it called, the theory behind it. So on course lecture, like the main course, which is Power System 1, the instructor will actually give you the theoretical background, and in this lab course, I will be actually showing you the um, like lab perspective. So that's why the first 2 weeks I will also cover the basic stuff. So from third week we'll actually start our like actual experiments. So that is module 2. That will be under module 2, which is single phase transformer. Then on third week we'll cover this topic, which is experiment number 1. And in this module, which is module 2, we will have 1, 2, 3, 4, and 5 lectures. So after that, we'll have module 3, which is 3-phase transformer. Then module 4 will be on induction machines. Module 5 will be on synchronous machines. Module 6 will be on DC machines. Then finally, the last one, which is also very important, which is renewable energy. Here, we'll be talking about all renewable energy sources and how we can actually convert energy like from another level to another level. So we'll be talking about those. So yeah, so these are the 7 modules. After this 13th lecture, um, I will have like on the 14th lecture, we'll have a group project, lab group project, and you will be given all necessary instructions on those. So this is basically the lab calendar. I have given the dates as well. So on these dates, I will be uploading these type of lecture videos, as well as other helpful materials, like for instance, animations, the actual lab demonstrations, and the theoretical aspects of it. Like, let's go to one of the modules that I've prepared. Like, let's so so this is module 1. I haven't actually uploaded it yet, but you will be like in each week you will get your like instructions and your lecture materials and everything. So for lecture 1, say for example this one, so these are the video lectures I'm gonna show you, and this is the PowerPoint presentation, and this video will also be uploaded. So these are all instructional videos, animations, just to make you actually comfortable, make you actually dig deep on these subject matters. So this is module 1. So we have module 2. So I told you under module 2 we'll have 4 lectures, 5 lectures. So and so each lecture will have its own like PDF version, like lab manual, lecture videos, like so. I will be giving you everything. So now I'd like to show you this lecture, like PowerPoint presentation, so that you'll be able to understand the basic concept of energy conversion. So as I told you, this energy conversion lab is under Power System 1. Why I say under? Because the theoretical aspect of Power System 1, like it actually covers energy conversion. So especially electrical energy conversion. So in this lab, those theories part will be demonstrated, and I'll be showing those to you. So for today's lecture, these are the outlines. So we'll talk about power system overview, conventional power system I'll be talking about. I'll also talk about problems associated with conventional power system, the change that is happening right now in our conventional power system. So what is a modern power system? Then we will see some instructional videos, some animations related to electrical grid, electricity, renewable energy, and then I'll be talking about energy conversion, electrical energy conversion, classification of electrical machines, renewable energy conversion. So these are the outline for today's lecture. Okay, so if you look at conventional power system, so normally power system consists of 4 major parts. One is generation, second one is transmission, third one is distribution, and fourth one is consumption. So if we look at this picture, a conventional power system, so these big chimneys, like they're actually they uh, like they're used in power plants. So this is basically a power plant, coal-based power plant. It could be coal-based power plant, it could be nuclear power plant. So these are all conventional power plants. So from here, and if you look at the loads, like there are 2 or 3 types of loads. Like these are commercial loads. That means offices, huge buildings, commercial spaces, say like shopping malls, big offices. So, and this is a village and farm, rural area electrification, and this is are residential area, these are factories. So these are different types of loads. But if we look at this picture closely, we can see that the power stations are actually situated quite far from the load centers. So these are different kind of loads, but they get power from very far away. Like, so we have power stations that generates electricity, and that is called generation section. So these are transmission lines. Say, for example, we have another power plant which is way above here, like very far away. So from that side, if you want to actually incorporate power from that side, that power plant, like say, for example, here, so we'll need some transmission lines. So these are the transmission lines, and they are transmission lines coming from outside this area, and power is injected to this transmission line um, from this power plant. And then these are all high power lines. So you will actually get the idea in power station, system 2 course about these aspects. In this lecture, like power system 1 lecture, we'll talk about electrical machines and energy conversion. But it's better to have a actually um, the total idea first. Then you'll actually understand why we need energy conversion, why we need power stations. So these are the transmissions line that carries power from a very far away to a load center, which is this area. So um, what is then we have covered generation, we have covered transmission line. What is this distribution? The distribution section is for different type of loads, we'll have different distributions. Say, for example, in factory where the power requirement is quite high, so their distribution system will be different. So distributions means that section will distribute power from the line, which is this one, to the load. So for factories or offices, commercial spaces, so that power, the required power is quite different than residentials or rural areas. So depending on the load profile or load requirement, the distribution will be different as well. So we have 2 layers or 3 layers distribution systems. So the distribution starts from substations. So this is one substation, this is another substation. From this substation, this one, say for example, this is a substation. So it carries power from here and distributes to the factory. From this substation, it uh, delivers power, distributes power to these residential areas, which is a like urban residential area, and these offices. And from here, we carry this power to another distribution line to these rural areas via rural transformers. Um, so and the final step, which is consumption, happens by these loads, factory loads, uh, residential loads, rural loads, and commercial loads. So as I've told you, we have like 4 different sections, but we'll focus right now on like generation, transmission, and distribution. So if we look at the generation side, um, the conventional power system has different type of power plants, and those power plants fuel sources are uh, could be coal, could be natural gas or nuclear power. Um, so they use boiler, hydro, or alternate sources. There are so many sources. We'll talk about some of the sources in this lecture, not in this lecture, in this course, but for today we're not going to focus on them. So generator, normally they actually generate very low voltage level, which is 15 to 30 kilovolts, depending on the capacity and the generation capacity exactly. So then in transmission line, if you look at the transmission line, the voltage is 69 to 765 kilovolts. So if you look at generations voltage level, so it's 15 to 30 kilovolts. But if you look at transmission lines, it is 69 to 765 kilovolts. So it's like there is a boost in the voltage from generation to transmission. It happens by the means of this transformer. So these transformers are electric machines that actually step up the voltage, in some cases step down the voltage. So depending on the application, we use this transformer either to step up or step down voltages. Then we have distribution section. I told you the distribution section distributes electricity among loads. So on the distribution section as well, the voltage level is quite low. So in transmission level, the voltage, like the transmission lines voltage is quite high compared to distribution and generation. So we need some electrical machines that are capable to uplift the voltage sometimes and down the voltage sometimes. And we also have in generation, transmission, distribution, and consumption section, it's not mentioned about consumptions level, but they also require protection scheme, relays, circuit breakers, sensors to protect the system. No, so problems with conventional power system. So I told you there are many power plants still today that uses coal to actually generate electricity. So in a conventional power system, generally speaking, in generating plant where coal is the fuel source, if it is if 100% coal is given here, 67% will be lost, only 33% electricity will be produced. I know there are some new generation of steam power plants driven by coal that can actually provide even better like percentage of electricity, but still it is quite low. And in transmission and distribution section, there are also losses, but it is very negligible compared to generation loss. And in case of end user utilization, if we don't have very good loads, if we have incandescent lamp like this one, which actually generates only 4% light and rest 94 or 88% actually these light bulbs generates 88% heat and 10 to 12% of light. In some cases it is only 4%. So the electricity, if you don't have energy efficient loads, then we'll have losses in this section as well. So there are problems with these conventional power systems, especially in the generation section, in some cases transmission, and in some cases distribution. So how can we actually mitigate this problem? Now, if we look at this is a statistics um, between like various kind of like resources that are used in power generation. Say, for example, coal, natural gas, nuclear, renewable, petroleum, and other like fuels. s- Uh, Say, for example, like such as diesel. So, if we look at 1950s, it was all coal at that time. A very few natural gas and uh, very few renewables at that time. But if you look at now, it is so from 2005, the number has like changed. So natural gas has gone up, not up, it's also down. But if we look at this one, which is green, renewable energy, so it is going like up in a steady state, a steady race. So if we look at network level 1, 2, 3, and 4, what are these? So network level 1, when the voltage level is 400 kilovolts, I have mentioned that um, the voltage in transmission line or in transmission network, the voltage is quite high compared to distribution or generation section. So normally in network level 1, when the transmission line, and when we're talking about transmission lines, the voltage is 400 kilovolt or 150 kilovolt or 132 kilovolt. At that level, the powers nowadays coming from either my biomass, coal power plant, nuclear power plant in some cases, or offshore wind, which is a renewable energy. In network level 2, where the voltage level is 60 kilovolt, and this is called trans-regional distribution network. So we have combined heat power plant or combined cycle power plant, wind farm, large scale industry. So this is one of the loads. If you look at the arrows here, so from biomass, coal power, or offshore wind, we are getting the power and feeding it to the transmission network. But in this case, we are getting power from combined heat and power plants, wind farm, but we are giving power to large scale industries. You remember I told you in some cases the factories takes a very large amount of energy. So in that case, so these are the industries I was talking about, large scale industries. So they actually they're situated in network level 2. So in network level 3, where the voltage is to 20 kilovolt to 10 kilovolt. So in generation scheme, in terms of generation, we have solar farm, wind farm, and energy storage. And as load, we have also energy storage, because these energy storage needs to be charged at certain point. Like say, for example, when solar in daytime, they produce electricity. So at that time, it can actually charge these batteries. And at night, when the solar farms are actually producing zero, at that time, this energy storage can actually produce a supply power to the grid. And in daytime, it will consume. And we have industries, medium level industries or regular industries in this section. In network level 4, local distribution networks, we have like 0.4 kilovolt, which is 400 volts level. We have micro wind turbine, rooftop solar panels, electric vehicle. So they can also supply like locally to this grid. So, and as load, we have heat pumps, residential loads, and electric vehicle. So these electric vehicles are just like an energy storage here on the like network level 3. Anyway, so if we combine all of this, so this will look like this one, which is the modern power system model. So in here, we will have renewable energies, which was not present in this conventional power system. Okay, so I must have actually missed one of the slides. So this is the slide I have talked about. I haven't actually talked about this one. So what is this? So the kilowatt actually generation. So it was billion kilowatts electric generation by major energy storage from 1950 to 2021, and this was from renewable energy sources. So it was talking about coal, natural gas. The sources were petroleum or diesel, renewable energy, nuclear, natural gas, and coal. Now we are gonna talk only on like renewable energy sources. So this is solar, the green was is wind, orange is geothermal, this is biomass, the blue is hydroelectric. So in 1950s, we only had hydroelectric power stations. In between 1970s and 1980s, we had a boom of hydroelectric power station, and after that we had a steady one. Like this is a very steady generation of electricity. Then if we look at biomass, we started biomass in middle of 1980s. Then we also have a steady biomass and geothermal. And if we look at wind, it is growing exponentially. Same goes for solar. It started like the boom of solar started in from 2010, and it is growing exponentially. So that's that for renewable energy sources. So now if we talk about modern power system model, this is one of them. So in modern power system, like conventional power, like similar to conventional power system, we might have power plants which are very large, but in case of the source, we are not going to use coal or natural gas or diesel. We might use natural gas in some cases, but we are not going to use coal. So it is not recommended actually. So anyway, let's say we have a power plant which is combined cycle power plant run by natural gas. This is that, and we have renewable energy sources, which is this one. This is a dam. This is hydroelectric. This is a hydroelectric power station. We have offshore, since it is not inside the mainland. So we have offshore wind farm. We have a converter here that actually uplift the voltage. So we have converters and transformers here that uplift the voltage and supply to this transmission line. So this is a transmission line, but it is advanced because there are so many power electronics are involved. Normally in conventional power system, if we go back, we can see there are so many cables. We have like total 1, 2, 3, 4, 5, 6, 7, 8. This is a 6-phase wire, like 3-phase, one like 3-phase. If we talk about, let's talk about 3-phase power system. Like 3-phase power system will have 3 lines, and if it has a neutral, then we can say it has 4 cables. But in a DC system, we will only have 2 cables. So compared to a AC transmission system, if we compare with a DC transmission system, we'll see the number of cable will go down. So in this example, in advanced transmission system, you see a DC transmission system. So these are all transformers, but in some cases they have galvanic isolation, like conventional. They use conventional transformers. In some cases they use what is it? The solid state transformers. We're gonna learn everything. Just I'm giving you an example, like very generic example. We also have solar panels as a secondary. I've mentioned, if you look back to this one, we have solar farms in level 3. So this is level 3. This is not part of this residential area. This is quite far. From here, it goes to this distribution substation, and it is supplying power either this way and this way. So in residential area, if we look at this, we have rooftop solar panels, we have net metering. That means smart metering system. We have electric vehicles, and we have like energy efficient loads. And if we look at the commercial space, they also have renewable energies. If we look at number 6, which is energy efficient consumption, we have electric train, we have energy storage elements, EV charging and energy storage elements here. And in number 4, which is this one, grid and smart meter security. We have smart metering on the net smart meter that is given here. So this is an example of modern power system. So it is happening in some places, especially in Europe and in the States. Like government and private companies, they are trying really hard to actually cut the fossil fuel consumption. They want to go for 100% renewable and 100% energy storage, like EV. Not 100%, but they're trying to go to that level. Anyway, now we're gonna see a video on electrical grid 101. Let's see this one.
The electrical grid. The electric grid is the network through which power is generated, transmitted, and distributed to consumers.
The electric grid
So whatever I have talked so far, it covered everything and it summarized. I think it'll help you to actually understand what I've tried to say. What I've tried
The
to
electrical
say.
grid.
Okay.
The elect
So now we'll see another video which is related to electricity. Let's see it.
Electricity.
So we have learned about
Electricity.
just a second. So we have learned about um, electric grid, then we have talked about electricity. So in this video, you will see the basic fundamentals of electricity and electric grid. Now we'll see renewable energy, so which is also important because especially in this course, if you look at the structure that I've given you, that all the materials are actually very relevant to the modern power system. So in generation section, like say for example, let's go back. So in generation section, we have energy conversion, like from here, if the source, like the resources that we normally use, like say for example coal or nuclear fusion, nuclear energy, or here we have water, here we have wind, here we have like photovoltaic solar panels. So we convert electricity from those sources. So And also in not only in the generation section, in consumption section, distribution section, and every section, we actually we are converting energy from one source type to another source type, or from same source type but in different levels. Say for example, I've talked about this transformer, right? Let's go back. So these transformers I have talked about, in generation section, the voltage is 15 to 30 kilovolts, but in transmission, the voltage is very high. So how we get that? We use transformers to actually uplift the voltage from that level to that level. So this is another kind of transformation, another kind of energy conversion. We are using the same energy, but we're like defining it in a different voltage level. So so in this particular course, we'll be actually learning energy conversion in generation section, in transmission section, and in distribution, of course, in consumption section as well. Like say, for example, in factory level, there are numerous electric machines that converts one form of energy to another. So we'll be learning those. I will be talking about those in very short time. Let's see another video which
The
is
electric
related to renewable energy, because this is also a part of energy. So now we have another video which is related to Energy 101. So let's see that video. We need that video as well. So if you look at this one, so this is the primary energy resources, like say for example uranium or coal or fossil fuel. So we have a conversion here, that is energy conversion, and then we convert this primary energy into electricity. Say for example electricity, it might be anything else, like it might be fuel for the car, but for this example let's consider is an electricity. So we're converting this coal or fossil fuel or nuclear energy to electricity. So there is one conversion. Then in distribution sector, we distribute this energy to to local like loads, or what is it called, factories. Then again we convert it. So energy conversion happens in different forms, in generation section, in transmission, in distribution, in consumption. In each and every level we actually convert electricity, or any other energy form per se. So what are the types of energy we use normally? So there are mechanical energy, chemical energy, nuclear energy, potential energy, electrical energy, thermal energy, kinetic energy, solar energy, wind, light, and sound. So these are the very generic forms of energy. So, and in this figure on the right, you can see the different energy conversion. Like, say for example, this is chemical energy. From this chemical, we can convert this chemical to electricity or electrical energy via like battery or diesel generator. Or from chemical energy, we can actually use it to run not electric car, normal car. And we have like, if we talk about a hybrid car, so we'll need chemical energy and also electrical energy. So by using car, we actually use like we convert from these chemical and electrical energy, we convert it to from kinetic energy. Then from chemical energy, we actually convert it to electricity, and then we convert this electricity to light energy and sound and light energy if we talk about television or mobile. Then we also can convert this chemical energy into mechanical energy if we look at if we talk about like rockets and jet aircraft. So we convert this chemical energy into mechanical energy. And if we talk about foods, if we consume food, we get energy to work. So these are different sorts of energy conversions. So in case of electricity, I told you in conventional or in modern power system, we have energy conversion, especially like electrical energy conversion in every aspect. In generation, we have, in transmission, we have, in distribution, we have, in consumption, we have. I have mentioned this. I'm not gonna talk too much about it since I've already mentioned it. Let's go forward. So classification of electrical machines. So I have talked about that in generation we use electricity. So from, if we look at this wind turbine, we actually convert wind energy to electrical energy by using wind generators. In here also we use generators. In here also we use generators. In here, which is photovoltaic cell, like PV, which is photovoltaic cell, we use photovoltaic cell to convert sunlight into electricity. But mostly, if you look at this, in most cases, we use generators to actually convert electricity from wind or water, hydro or coal or nuclear or any other very generic power plants, natural gas and other like petroleum. So that is a kind of an energy conversion unit. We call it generator. So this is a generator. So and this is called a turbine. So what happens is if you boil water with the help of a fuel, it could be coal, it could be what is it called, nuclear. We simply boil water and this water becomes steam. This steam is used to actually rotate this turbine. It is coupled with this generator. So if the turbine rotates, one part of this generator is called rotor. It also rotates, and then we get electricity on the other side. So this is a generator, which is an electric device. So this uses as energy conversion elements. And if we look at industry, there are quite a lot of rotating machines that rotates that, like if you talk about robotics, where um, um, they use hands and arms like humans. They use electric machines to convert electrical energy to mechanical energy. So in conveyor belts, say for example, so in conveyor belts, they use electric motors. So in case of, if we talk about generators is taking mechanical energy here and converts electrical energy. In case of a motor takes electrical energy and converts mechanical energy. So generator generates, motor rotates. So electric machines are normally two types. There are two types. One is static machines, another is rotating machines or dynamic machines. So what are static machines? That are called transformers. I have mentioned earlier that in every section, when we actually needed to uplift the voltage, if we remember it correctly, let's go back here. So in generation, the voltage is 15 to 30. In transmission line, it is 69 to 765 kilovolts. So we needed some electrical device or some electrical machines that converts voltage from one level to another. So that is actually done by a static device, which is called transformers. This is a three-phase transformer. So this is a static device. It doesn't move, it doesn't rotate. But if we look at dynamic machines that I've just mentioned, a generator. So this is an example of a generator. So the uh, the outer part is not this is the outer part and this is the inner part. So inner part rotates and the outer parts stays static. So that's why they are called dynamic machines, because one of the parts of this machine, generator or motor, moves. So the part that it moves is called rotor, and the part that it doesn't move, that is called stator, because it is stationary. So if we look at this one, this is an example of EV motor. So the outer layer, which is this one, we're going to cover them all in theory and in lectures. But since this is an introductory course, I'm not going to explain too much. But since the picture is here, let's talk about it. So this is the upper section or top layer. So this is stationary and this is static, and this is the bottom, like inner layer, so which is called a rotor. So let's talk about electric machines. So this is one type of classification and this is another type of classification. So electric machines can also be classified in terms of their input, like input take, like, or output generation. One is direct current machine that takes or gives direct current, that means DC, and another one is alternating current, which is AC machines. If we talk about, like, say for example this one, uh, a DC generator generates DC power or direct current, and DC motor takes direct current. So uh, the input of a generator normally is the mechanical, so it will be the same, but the output of DC generator will produce direct currents. Same for the DC motor. The input will be DC electricity, but the output will be a mechanical output. But in case of an alternating current machines, say for example this one, induction machine. So induction machines can be also classified into two sections. One is induction generator and another is induction motor. So induction machines takes or gives alternating current, as the name suggests. Same for synchronous machine, same for this machine and this transformer. So transformer, this type of transformer doesn't work with direct current. So this is super important. We're going to cover all of them. So for today, we are not going to talk too much. Let's go to the next slide. And in case of renewable energy, these are different sources, as we have talked about. We have seen a video of it. So ocean energy, which is also called tidal energy or hydroelectric energy, it can be converted into electricity. Wind energy can be converted into electricity. Solar can be also converted into electricity, and thermal. Geothermal, which can also be converted into electricity or thermal. Biomass, same, electricity to thermal. So this ocean energy, whatever we are getting from this, like say for example electricity, that can be used in mechanical storage. And in case of wind, it can be stored in electromechanical storage. So there are different types of storage elements as well. We are not gonna bother about this one. This is just to actually get you guys to introduce with the whole energy conversion system. So that's all for these lectures, I think. If you have any question, you can always email me. You can always text me. You can also open a link or in a discussion section in Canvas. Let me show you that one also. So that's the that is the, what is it called, Canvas. So there will be discussions, open discussions. You can actually talk about this if you have. This is open forum, so if you have any question, you can post your questions here. And also please read the whole thing, especially this one, because I have mentioned in here, I have mentioned how to do what. It's very important to note that every week on Friday at 5 p.m. GMT4, that means here in the US time, I'll be actually uploading lab materials in like PDF forms, in video forms, and in MATLAB Simulink forms. I'll be talking about those later, and you will get instructions like this video or in written form how to provide lab reports or assignments and everything. I have told you. Let me show you this one. If you see, this is the first week's lecture. So after this lecture, you are supposed to give me report on this one, lab report 1, which will be on lecture 1, and the due date says this one. So before 9 you'll have to actually upload your assignments, that means lab report. So whenever you see assignment, that means a lab report. So I will keep you keep you updated on those assignments as well, so which are lab reports. And whenever you upload anything, please remember, if it is a lab report, then this should be the format. So what is this? This EC stands for energy conversion, then LR stands for lab report, 02 stands for the number of which number you're submitting. Say for example, this is lab report 1, then you will say LR01. If you're gonna submit this one, then it will be LR09. So LR09 underscore your Panther ID. So I know you all have your Panther ID. This is very crucial to actually rename the file. That means that PDF file that you're gonna upload, please rename it like so. For quiz, there will be 2 quizzes in total. Let me go back to this one. Yeah, one will be after 7th lecture, on 7th lecture, sorry. I will be actually posting you this one, and I will be giving you all necessary instructions. After some time, you'll have to submit quiz 1 on that very day. So please be aware of that. I will give you all the necessary instructions and guidelines. Don't worry about it. But do not miss any deadlines. Please do not miss any deadline. If you have any problem, like, just text me. If you find it very difficult, just text me, email me. I'll give you like 24/7 help. Don't worry about it. Within 24 hours, I'll be giving you instructions or guidelines. So the quiz 2 will be, I'll give you that. I'll post it on 11. 11 means, by the way, this is American style, so 08 means month, 25 is day, and this is year. So 11 means November 17th. I'll be posting this one. And there will be a lab group project. So I'll divide the whole lab into different sections, different groups. So there will be like 4 or 5 group members, could be 3. I'll have to check. So like, you will be given task, like that group will be given task differently. So, and you'll have to actually submit that. You will get 2 weeks of time. Like, see on 14th lecture, I'll be giving you this one with instructions on this day, and you will get 2 weeks from that one to actually submit this one. Okay, let me give you, so there will be a final exam as well. It will be a combination of MCQ, short and long answer questions. The quizzes are also short answer questions. If I have given you only an MCQ questions or anything, if you'll have to actually upload a file, then you'll have to remember this manner. So, but if the quiz is automated, then you don't have to upload anything. You will be given all the necessary information. But remember, if you're asked to actually upload a file, the file name has to be like this for a quiz. For final exam, it'll be like this. So this is, and What else? Yeah, the lab course also includes a special group project related to electric machines and energy conversion. The project includes a report submission and recorded oral presentation. Group information will be provided later. I'll be providing that while renaming the project report file, so the same information is here. So you will be posting two different files for this one. One will be your presentation video, another one will be the report. So this is the report, project report one, and this is what is it called, the video one, project video. In that case, you don't need to actually provide your PID. It will be group 1 or group 2 or group 3. I'll edit this on out. So then we have safety rules and other policies. I'll highly recommend you to actually go through all of this. So this is course communication discussion forum. So how you're gonna actually use all of them. And lab reports. I have talked about lab reports here again. I have talked about how I'm going to actually evaluate your lab reports on the basis of this rubric. So please have a look at them. And this is about quizzes. This is about the final exam. This is about the project report. And these are different letter grade distribution table, course calendar. I will be actually this is not updated, but you will get the updated version of it very soon. So I think that's all for today. Another thing, so this is a video number 1 for your for this lecture. There will be another video which I will show the actual lab, where I will actually demonstrate those electric machines to you. So not that one will be an introductory class as well. I'll show you different electric machines, like say for example transformers I have talked about, the electric machines I have talked about, motors and generators I have talked about. So I will show you our labs like capabilities and our labs equipments. So there will be power supply, there will be electric machines, there will be measurement equipments, there will be like loads, different types of loads. So I hope that video will actually make you understand what are the types of equipments that we are going to use in future lectures. And also for your part, you will actually see those lecture videos. I'm talking about upcoming classes. So I will demonstrate the practical aspect of it, but in some cases I'll give you simulation files like MATLAB Simulink. So this software, I will give you some simulations files to simulate so that actually you can actually have a hands-on experience as well. Since I know it's an online course, but I'll give you my 100% to actually make you understand the whole concept of and the practical aspect of energy conversion, especially electrical energy conversion. So, and remember, do not forget to actually submit your lab reports in assignment forms. So I will post on this one. So the first lab report will be on lecture 1, which is this one. So this is very basic stuff, whatever we have learned so far, and I have given. So okay, just a second. So whatever I have given to this like from this lecture, there will be very basic questions very basic questions. You'll have to actually go back to your basic electricity courses, like electric circuit courses, energy physics courses, to actually get like recap whatever I'll ask. So those are very basic stuff. So this is lab report 1, and then in next class we'll talk about magnetic circuit. So we are not going to actually demonstrate anything. We'll simulate using this software. This is MATLAB, and we'll use Simulink. I'll be giving you all the simulation files. You'll have to simulate them. In some cases, you need to actually generate and design on your own. So if you find difficulty actually using this software, just let me know. I will provide some tutorials on that as well. So that's all for today. If you have, I'm going to tell you again, if you have any questions, feel free to text me, email me, or post something on the, what is it called? The discussion thing. Thank you so much. Take care.